Okay, in this video, we're going to begin our discussion on ellipses. An ellipse is the locus, and there's that word again, and a locus is simply a collection of points. And an ellipse is a collection of points such that the sum of the distances from any point on the ellipse, so if you take this point or any other point on the ellipse, then the sum of the distances from two fixed points, and we call those two fixed points the foci, which is plural for focus. We have a focus here and a focus here. So the two foci, those two distances, D1 and D2, if you were to add them together, no matter where you are on the ellipse, the sum will always be the same for D1 and D2. So D1 plus D2 remains constant for all points. That's the locus of points to where those sums are all the same. Let's identify the parts of an ellipse. And here you see a horizontal ellipse because it's a little bit wider, and we'll talk about those two types in a second. The major axis. The major axis is the longer axis, and that's an S, the longer axis of symmetry, and it contains the foci. So your major axis would be this axis right here. It cuts it perfectly in half. The minor axis is the shorter axis of symmetry, and it connects that co-vertex and co-vertex, and you see here that the axis of symmetry connects as vertex to vertex, which we'll talk about just in just a second. The center is the intersection of the major and minor axis, and we see the center right there. It cuts it perfectly in half horizontally and vertically. The vertices are the endpoints of the major axis, and the co-vertices therefore would be the endpoints of the minor axis. Okay, now the two different types of ellipses. You have a horizontal ellipse, and notice that it is wider than it is tall. Then you have your vertical ellipse, which is taller than it is wide. The vertices, and again, remember that the vertices are the endpoints of the major axis. Now, a horizontal ellipse would have a major axis that is horizontal. A vertical ellipse has a major axis that is vertical. The vertices are a distance of plus and minus a units away, and we'll talk about that more in just a second. The co-vertices are plus and minus b units away from the center, and you see the co-vertices are located here and here. The length of the major axis, therefore, if the distance from here to here is a, then the entire major axis will have a length of 2a. The entire minor axis will have a length of 2b for the same reason. The foci are lengths of positive, negative c units away. So this is a focus, this is a focus. Those are the two foci, and these are two also foci. Now here are your formulas for the two types, the horizontal and the vertical ellipses. And here they are. X minus h squared over a squared plus y minus k squared over b squared equals 1. And then the only difference here is the a squared and b squared are flipped. Very important to know this. A is bigger than b. In every one of these, a is the larger number. So if this is bigger than this number over here in your formula, then this is the a. If it's bigger over here, then that's the a. Remember that a is always, with an ellipse, a is always bigger. So now let's talk about how to graph these. We're going to write it in that standard form, which we just saw. We're going to graph the center, HK, just like as before. Graph the vertices. Remember, the vertices are going to be found with A, the larger number. The co-vertices are going to be found with B, the smaller number. And then we're going to use this formula. This is how we find C. With an ellipse, c squared equals a squared minus b squared. And that's going to be the distance to each focus. So here's our first problem. X squared over 64, larger number is A. Y squared over 25, smaller number is B, equals 1. So therefore, in this problem, our A value, A squared is 64, so our A is positive and negative 8. Our B is positive and negative 5. Okay, now let's talk about the center next, though. We should have probably talked about it first. Look and see if there's any transformations, any pluses and minuses on the x and y's. If there are no transformations, then our center is located at 0, 0. So here's the center. If the larger number is under x, then this is going to be a horizontal ellipse. and that's the case here. If the larger number is under the y, then it's a vertical ellipse. So therefore, here's what we're now going to do. Let's graph our vertices by using our a value, and it's horizontal, so we're going to go right and left. So 1, 2, 3, 4, 5, 6, 7, 8 to the right and 8 to the left. That's your vertices. You can put v's there if you want to. Then your co-vertices is going to be positive, -5. So go up 1, 2, 3, 4, 5, and go down 1, 2, 3, 4, 5. And there are your co-vertices. So you have vertices located at, I'm going to write it like this just to save time, positive and negative a0. Here's positive a0. Here's negative a0. You have co-vertices located at 0, positive and -5. Now the foci. To find the foci, you have c squared equals a squared minus b squared. And again, you can actually pull a squared and b squared straight from here. So c squared is equal to 64 minus 25. C squared would be 39. So c is the square root of 39, which is about 6.24. So therefore, your foci, you can write it one of two ways, and I'm just going to do it this one time. If you want it exact, again, your foci are located on your major axis. So 6.24, 1, 2, 3, 4, 5, 6.24, somewhere right in there, and somewhere right in there. That's going to be the foci, F1 and F2. So you can write it as exact, which would be plus and minus root 39, 0. Or you could write it as plus and minus 6.24, comma 0. But anyway, that's all you need. Connect your vertices and your co-vertices, and here's your ellipse. Okay, the next one. Let me erase that. There we go. Number 2. Again, first step, let's identify our center. Right 5, down 2, so the center is located at 5, -2. Let's go ahead and plot that point. Let's identify our vertices and co-vertices. Since the larger number is under the y, then this is going to be a vertical ellipse. So therefore, your a squared is 36. Your b squared is 9. So that means that a is plus and minus 6. B is plus and minus 3. The larger number is under the y, so we're going to go up 6 and down 6. Let's go ahead and do that first. And there are your vertices. Your smaller numbers are under the x, so from the center, let's go right 3 and left 3, and there's your co-vertices. So therefore, let's go ahead and label those points. Our vertices were located at this point, which is going to be at 5, 4. And the other point down here, which is located, now notice that your a value is 6, so you could just add 6 and subtract 6, so that'd be 5, 4, and 5, -8. Your co-vertices, we went right 3 and left 3, so let's take our x value and change it. So right 3 would be 8, -2, left 3 would be 2, -2, so there's your co-vertices. Your foci, we know that c squared equals a squared minus b squared. So c squared is 27, or that's the square root of 9 times the square root of 3. That's your exact. Or the approximate value is going to be about 5.2. So from our center, we're going to go, again, it's located on our major axis. So let's go up 5.2 and down 5.2. And there are your two foci. Again, from the center, which was 5, -2, we're going to go up 5.2 and down 5.2. So your two foci are going to be located at 5, 3.2. And then go down 5.2, be 5, -7.2. There's your two foci. Connect your dots, and here is your ellipse. Okay, the next one. I did it again. Let me erase that. Number 3. Again, identify your center. So that's going to be left 7 and up or down 0. So your center is located at -7, 0. Let's go ahead and plot that, which is going to be right there. Larger number right here is your a squared is under the y. So this is going to be a vertical ellipse. Smaller number b squared is under your x. So here a is going to be plus and minus 9. B is going to be plus and minus 2. So let's go ahead and graph those. Again, remember your plus and minus 9 is going to be vertical, plus and minus 2 will be horizontal. So there are your vertices and your co-vertices. So let's go ahead and find those. Our vertices, we went up 9 and down 9 from our center. So it's going to be located at 7, -7, 9, and -7, -9. Or you could have just done the plus minus sign there. To find our co-vertices, we went right 2 and left 2 from our center. So that's going to be at -5, 0 and at -9, 0. We know that c squared, to find our foci, c squared equals a squared, which was 81 minus b squared, which is 4. So c squared to be 77. So c is the square root of 77, which is about 8.8. So our two foci, we're going to go, because it's on the major axis, we're going to go up and down 8.8. So that'll be located at -7 and then plus and minus 8.8. We can do that because of the 0. So that's going to be really close, nearly right on those vertices. And the reason this ellipse is so elongated is because those foci being so close to the vertices, and here is your ellipse. There you go. And the next one. Number 4. On this one, our center has been moved right 2 and up 6. So therefore, the center is located at 2, 6. Let's go ahead and plot that. Let's identify our a squared, which is here, larger number. B squared is 6. So therefore, our a is going to be plus and minus 4. Our b is going to be plus and minus the square root of 6, which is about plus and minus 2.4. Since the larger number is under our x, this is going to be a horizontal ellipse. So let's go ahead and go right and left 4. And let's go up and down 2.4. So since we went right and left 4 to find our vertices, let's add 4 and subtract 4 from our x. So that'd be -2, 6 and 6, 6 would be our vertices. That's a horizontal major axis. We went up and down 2.4, so that's located at 2, 3.6 when we go down 2.4, and 2, 8.4 when we went up 2.4. To find our foci, again, c squared equals a squared minus b squared. So c squared is 10. So therefore, c is going to be plus and minus the square root of 10, which is somewhere around 3.2. Again, that's going to be located on the horizontal. Let's see, 1, 2, 3.2 is somewhere right in there and somewhere right in here. So our foci, we went right 3.2 and left 3.2, so that's going to be 5.26. And left 3.2 would be -1.26. Connect your dots, and here is your ellipse. Okay, the next one. Number 5. First, identify your center. 0, -4 is how that's got shifted. So 0, -4 is your center. Go ahead and plot that point. It's located right there. Next up, identify your a squared and b squared. Here would be your a squared, the larger number, and b squared would be 20. So therefore, a is going to be plus and minus the square root of 75, which is about 8.7. And your b, since b squared is 20, your b is going to be plus and minus about 4.5, which is the square root of 20. So therefore, this is going to be larger numbers under x, so this is going to be a horizontal ellipse again. So we're going to go right and left 8.7 to get our vertices. So that's going to be right and left 8.7. We can just do our plus and minus there. So that's going to be located somewhere right in there and right in there. We're going to go up and down our b value of 4.5. So that's going to be located at 0, if you go up 4.5, you get 0.5. If you go down 4.5, you get -8.5. So let's go ahead and plot those points. Again, to find your foci, we know that a squared minus b squared equals c squared. So c squared is a squared minus b squared. So c squared will be 55. So that means c, the distance to our foci, is going to be plus and minus the square root of 55, which is about 7.4. Again, this has a horizontal major axis, so let's go right and left 7.4. So the foci are going to be left at plus and minus 7.4, negative 4. And let's go ahead and plot those. And finally, let's connect our dots, and here is your ellipse. Okay, on the next section, we are going to have to rewrite these in standard form, so we're going to have to change it. Now, the biggest thing I noticed about ellipses is this number over here, it has to equal 1. So to get this one in the right form, we're going to divide everything by 225 to get our equals 1 over there. And the rest of this stuff we're just going to reduce. 25 over 225 gives you 9. 9 over 225 gives you 25, and then 225 over 25 again gives you 1. So you have x squared over 9 plus y squared over 25 is equal to 1. Now it looks like the standard form. Okay, number 7 is a little bit different. You notice you have x squares mixed with x's, and you do it just like you did with circles. We're going to group our x squareds with any x's, and we're going to leave a blank. We're going to group y squareds with any y's. We don't have any y's, so we're going to leave that put, and we're going to move our constant to the other side the same way we did circles. Now, here's the only difference. If there's a number out front, it must be factored before you complete the square. So let's factor the 4 out of both of those terms. Now, let's complete the square. Inside of parentheses, half of this, multiply it times itself, so we're going to add 9. Be careful because there's a 4 in front of that parentheses that you just added 9 inside of. So technically to the left side, you added 4 times 9 to the left side, so let's add 4 times 9 to the right side. So now let's factor. This is a completed square now. It's going to factor into x times itself, and then adds, multiplies will be a positive 3 times a positive 3. And now it looks a lot like that first problem did. 28 and 36 is 64. In order to get the 1 over here, we're going to divide all 3 terms, and it is just 3 terms. We're going to divide them all by 64. We're going to reduce the 4 and 64, and that gives us a 16, and now we're in standard form. We have x plus 3 squared over 16 plus y squared over 64 is equal to 1, and there's your standard form. Number 8, doing the same thing, group your x's, 9x squared minus 36x, leave a blank, plus y squared plus 10y, leave a space, move the constant to the other side. If there's a number in front, let's make sure that we factor it first. So pull out the 9, and you're left with x squared minus 4x. Leave that blank there. Nothing in front of the y squared, so you don't have to worry about it. So there is now what we have. Now let's complete the square. Half it, multiply it times itself, we're going to add 4. But again, be careful. There's a 9 in front of that parenthesis, so 9 times 4, you actually added a 36 to that side. Half it, square it. There's no number in front, so we don't have to worry about that. We're going to add 25, so let's add 25 over here. And now we're in good shape. Let's factor. That gives you a perfect square, x minus 2 times x minus 2. Let's now factor this. Perfect square gives you y plus 5 times itself. On the right side, this is 61 minus 52, which is 9. So we're going to go through, and in order to get this to be a 1, we're going to divide all 3 of these terms by 9. 9 over 9 reduces to a simple 1 on bottom. So you now have x minus 2 squared. And if you want to put that over 1, just to make it look like they're used to looking, y plus 5 squared over 9 is equal to 1. There is your standard form. Number 9, let's do the same thing. Group your x's. So you have 9x squared plus 36x. You can leave a space. Plus 4y squared minus 32y. You can leave a space equals 224. If there's a number in front of the x squared or y squared, it must be factored out to get this to fall out right. So you're left with x squared plus 4x. I'm going to leave that space again. Factor out the 4. You're left with y squared minus 8y. Leave a space equals 224. Let's complete our squares. Half it, excuse me, half it squared, you're going to add a 4. Since there's a 9 out front, 9 times 4, you added a 36 to that side. Half it, square it, you're going to add 16. Since there's a 4 out front, 4 times 16, you actually added a 64 to that side. Now let's factor. Should be a perfect square. X times itself, adds, multiplies would be positive 2. It's always half of this middle term. Bring down your plus 4. Perfect square. Y times itself gives you y squared. Adds, multiplies should be half of this negative 8, which is negative 4. That does work. And then when you add the right side, it gives you 324. Everything now gets divided by 324, all three terms, in order to get that equals to 1. Let's reduce this. 9 goes into 324 36 times, so that reduces to a 1 and a 36. 4 goes into 324 81 times, so that reduces to a 1 and 81, and this reduces to just 1. So I now have x plus 2 squared over 36 plus y minus 4 squared over 81 is equal to 1. There is your standard form. Number 10, group your x's. X squared plus 10x, leave a space, plus 4y squared minus 16y, you can leave a space, equals 155. Nothing to factor out here, but we do have a 4 to factor out with our y, so let's just bring down the x squared plus 10x. Factor out a 4, you're left with y squared minus 4y equals 155. Let's complete our squares. Half it, square it, gives you 25, add it to both sides. Half it, square it, gives you a positive 4. However, there's a 4 in front of the parentheses, so add 16 to both sides. 4 times 4. Now let's factor. Gives you x plus 5 times itself, plus 4 times y minus 2 times itself, equals 196. Divide all three terms by 196 to get your 1 over there. And that gives you x plus 5 squared over 196 plus, let's see, I believe that would be 49. This reduces to 1 and 49. So that'd be a y minus 2 squared over 49 is equal to 1. There is your standard form. Another one, 25x squared. Group it with your plus 150x when you move it over. You can leave a space if you'd like. Plus 4y squared, move the 16y over, and leave the 159 on the other side. Let's factor the 25 out of the x squared and the 150x. That leaves you with plus 6x. Factor the 4 out of the second set of terms. That leaves you with y squared minus 4y. And that, again, is equal to 159. Complete each square. Half square, you're going to add 9, but you actually added 25 times 9, which is going to be, we got to add it to both sides, 225. Half it, square it. 4 times 4, you add it to that side, so add 16 to the other side as well. Factor leaves you with x plus 3 squared. Bring down the 4. Factor leaves you with y minus 2 squared equals, when you add all that together, it gives you 400. To get equals 1, let's take all three of these terms and divide it by 400. And I'm going to go ahead and reduce that. The 25 and 400 reduces to a 1 and a 16. The 4 and 400 reduces to a 1 and a 100. And this obviously reduces to 1. So final answer, x plus 3 squared over 16 plus y minus 2 squared over 100 is equal to 1. Okay, finally we're going to be talking about eccentricity. The word actual eccentric, if you were to look it up, an eccentric person is like a quirky or an odd person. So when we're talking about eccentricity, we're talking about, I guess you could think of it as how odd your conic section is. And what we mean by odd is how different from a circle is your conic section. Okay, and the eccentricity of an ellipse is the ratio of C to A. This value will always be between 0 and 1. Now, if we were to have an eccentricity of 0, that means it's a circle. So the closer, or excuse me, the further it gets away from 0, the further it gets away from a circle. The closer it gets to 0, the more it's going to resemble a circle. The eccentricity determines how circular or how stretched an ellipse is. So let's try this. Eccentricity, again, is simply the ratio of C to A. So let's determine the eccentricity of each ellipse. So again, we'll see E is equal to C over A. So here is our A squared value. So therefore, our A is going to be positive or negative 7. And for eccentricity, we're just going to use the positive value. We know that C squared is equal to A squared minus B squared. So C squared is equal to the square root of 13. So C squared is 13, so C is equal to the square root of 13. So therefore, our eccentricity here is going to be root 13 over 7, which is going to be somewhere around 0.52. That's how far away, again, that you are. You're kind of in the middle there with 0.5. So let's do another one. Let's go ahead and find our C value first. C squared is equal to A squared minus B squared. That's 25 minus 9, which is 16. So your C value here is 4. And again, we can just use the positive value. Our A value here, A squared is 25 right above me, so therefore my A value is 5. So the eccentricity is equal to C over A, which is going to be somewhere around 0.8. Okay, now what I want to do is I'm going to take and I'm going to graph each of these. Now I am going to graph them without their transformations, just to where they're centered at 0, 0, because I want you to understand what eccentricity means. The first circle had an eccentricity of 0.52, the second one 0.8. This one was much closer to 1, much closer to 0 than the second one. The closer you are to 0, the closer it's going to resemble a circle, and that's what we see here. The first one's in red, the second one's in blue. Notice the eccentricity, since it was closer to 0 of the red one, it resembles more of a circular type shape. The second one, the blue one, is more of a true ellipse. It's more elongated. So again, the higher the eccentricity, the closer you are to 1, the more stretched out you're going to be. The closer you are to 0, the more it's going to resemble a circle. Okay, the next one. Again, let's find our C value first. C squared equals A squared minus B squared, which is 21. So therefore, our C is going to be the square root of 21. Our A value, again, is 25. So our eccentricity is going to be, again, our formula was eccentricity was C over A. So we have C, which is root 21, over A, which is 25. That gives you an eccentricity of about, and I messed up on that, our A squared is 25, so our A value is going to be 5 and not 25. So that gives you an eccentricity of somewhere around 0.92. Now that should be an extremely stretched, skewed an ellipse. And there is the graph, and you see it's a very elongated ellipse. Okay, finally, number 15. Again, we have C squared is equal to A squared minus B squared, which would be 5 in this case. Therefore, C is going to be the square root of 5. Our A value, this is A squared, is 45. So therefore, A is going to be the square root of 45. So our eccentricity is going to be the square root of 5 over the square root of 45. Now you can, since both of those are square roots, you can reduce them. That's going to be the square root of 1 over the square root of 9, which is an eccentricity of 1/3.